So Bhagwat has not been able to run the script on HDFS, did not get a chance to debug. Did Okay. So for Hari, the scripts are running fine. Uh, and maybe actually Bhagwat, I also did not get to debug your scripts. Let me also get some time out and then debug. All right. Okay. 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 So today we are going to cover Zookeeper first. Then we will rediscuss some of the H part about HBase. Okay. So okay. Yeah. So first we will talk about something called Zookeeper, and then we'll talk about other aspects. So for HBase, as we discussed last time, to coordination between HBase and the region servers. So basically, let me do a little recap. Let me do a little recap. Okay. So here, okay. So this architecture will tell you clearly like what does HBase do. Okay. Or a better one would be to have this one. Okay. So So in the HBase, there is a server called HBase is basically a database. This is the closest we could come to a database in case of handling big data. And these are column oriented database. Instead of saying column oriented, I would like to call it column family oriented. Okay. So how many of us actually went through the video, and who wants me to recap? Suksavat, do you want me to recap? Kalyan, Bhagwat, Hari, and Anto? Okay, Suksavat is clear. Bhagwat wants a little recap. Anto wants a little recap. Okay, okay, okay. Suksavat, are you okay if I do a little recap for all the people? Okay, okay. So basically, in the first half, we discussed about the challenges with respect to the old systems. All right, and why did we have to have a NoSQL database? In very simple words, the reason we wanted a NoSQL database, a database whose tables are spread across multiple machines instead of a single machine. So in very simple words, if I have to summarize everything, a NoSQL database is a database whose data is spread across multiple machines, and to coordinate with these multiple machines, it has to have an ID column, a unique identification column with which it can identify each row in the table. Okay, so those are called NoSQL databases, and there are various kind of databases, and HBase lies in the column oriented one. And consistency wise, it is consistent and partition tolerant, meaning it runs on multiple machine and it is very consistent, but it is not, and it little bit sacrifices the availability in favor of consistency. Okay, here we discussed about the problems with in case there is a single machine A single machine, if there is a single machine and two people are trying to read and write, that means in case that machine goes down, in case that machine goes down, then you cannot access it. Hence, it is not partition tolerant. Similarly, in case one person is writing to a row, it is not available to the other person trying to access the same row. Okay, only the dirty reads will be available. Again, that will be inconsistent. Then we have something called, you know, replication, where you have two machines. Users are writing to one, and users are writing to one, and the readers are reading from the another one. All right. So for such system to exist, you need to have a replication from one machine to another. Okay. So this particular architecture where people are writing to one machine and the readers are reading from another machines, and there is a replication happening. The only problem is that reader will get to see the data after some time, which means it is not immediately consistent, it is eventually consistent. Okay. Now there is a third kind of architecture we can think of is readers and writers are reading from the same machine and writing to the same machine, just that we have a backup. So here it is consistent because similar to the first diagram, but it is neither available nor partition tolerant. Sorry, it is not available, but it is partition tolerant because anything we are writing has a backup copy. Similarly, in case backup copy goes down, the other one is there. Partition tolerant means in case either of the machine goes down in the network, there is no data loss at all. Either of the machine. Okay, you have thousands of machine. If any of these machine goes down in this network, and in case there is no data loss, that means that you are completely fault tolerant. I mean partition tolerant. Alright. So this is the cap theorem, which says this diagram demonstrates that in in these three topologies, neither of them is able to give us consistent, available, and partition tolerant store. Okay. So these are the very important thing to remember, that when we say cap theorem says that either of these three, will be missing. Not you cannot have all the three in any database. Okay. All right. So in a simple way, this is the RDBMS story. In a typical scenario, when you have a database and you are doing building a public system, building a public service which will have millions of users. So you start with, okay, so you start with say you got a public launch today. You are launching it today. So you moved from the local workstation to the shared remotely hosted MySQL instance with a well-defined schema. Okay. So just a second. Which one are you seeing? Okay, we don't need, this one is a bogus slide. Okay, this requires to be deleted, this need to be deleted. Okay, and today we are talking about this. Is it visible to all of us? Oh, 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 sorry, I'm extremely sorry, because this thing keeps on showing me only the one which I select. Okay, now it is right. Yes, recording is on.